all of you to Chaco Culture National Historical Park. My name is Kelly. We will have a start party after this presentation that will be outside. We don't really have an in time for that, but we'll have some telescopes set up. Several of our volunteers are hiding in the crowd right now. And when we're done with the presentation, we can either exit out this door or exit out the front as you guys came in. A few things I will caution you all about, just be careful as you're walking, especially once it starts getting darker. We've had people trip, including myself, on these curbs, so just be careful, watch your step. If you've got red lights, that's preferred to white, but once you're headed out, if you do need to switch to white lights, that's understandable. Just try to be respectful of others as you're visiting us tonight. This presentation, I'm not going to ramble on too long about it. We're going to have Andrea do the real introduction here. But we were very fortunate to kind of have this marvelous collaboration fall into our laps this weekend. Andrea was the one that reached out to me about this presentation, and we were really happy to host. And I'm really excited to learn both from Agnes Chavez, who is an artist, and Dr. Julia Bluebird, who is an astrophysicist. I'm not going to go too far into it. I'm just going to turn it over to Andrea and let her introduce everyone. Thank you all for being here.
Kelly. I'm so excited for this opportunity to be at Chaco. My name is Andrea Poley. I'm a professor of art and computer science at UNM, and I'm a member of an organization called SciArt Santa Fe. We promote excellence in art and science in that intersection that we call science and art. And one of the ways we do this are by hosting these, we call them lasers, Leonardo Art Science Evening Rendezvous, and usually it has an artist and a scientist, so we're excited to have an artist and a scientist today. I'd like to thank our wonderful partners, Chaco, and the Star Party staff, especially Kelly and Ed. Is Ed here? Oh, hey, Ed, nice to meet you.
Nice to meet you.
Thanks for your help. We have generous, also connections coming from Christine Casano, who's an artist and a member of our community, and Alice Monet. I don't think Alice is. Oh, great to see you. We also are thankful for generous support from for this series, which there's actually an exhibition in Santa Fe at the Santa Fe Art Institute. We've got one more event on Sunday evening in Santa Fe at the Art Institute at our exhibition. So our support for that from the Art Institute, from UNM, from the NEA, and from New Mexico Arts. And you can find out about our upcoming programs. There's some information floating around. SciArtSantaFe.org is the URL. So without any further delay, I'd like to introduce our two amazing speakers, Agnes Chavez and Dr. Julia Bluebird. They're giving a special Woven Skies laser. The name of our series and our exhibition is called Woven Skies, SciArt from Air to the Cosmos. Agnes Chavez will share, someone I've known for 15 years, I think, at least, and worked together with a lot of cool art science projects, and have been following her work all over the world for a long time, including with Fermi Lab, where she's an artist in residence now. She will share Space Messengers, an immersive and interactive installation that invites participants to explore the universe through the lens of particle physics, astrophysics, and cultural cosmologies and future thinking. And I'm so glad to get to know now Dr. Julia Bluebird, who is an astrophysicist, a Lakota educator, and STEMarts collaborator, who will share how she brings youth leaders into contact with the cosmic web and how galaxies grow and evolve within this underlying structure of the universe. She will share Indigenous perspectives discussing how traditional knowledge aligns with and enhances modern astrophysics. So, without any further delay.
Hello, everybody. It's so great to see a packed house. Matakiapi, Julia Bluebird, Amachiapi, Pine Ridge, South Dakota, Hamatahan, Ayash, Socorro, New Mexico, LYT. I'm Julia Bluebird. I grew up in Pine Ridge, South Dakota, and I currently live in Socorro, New Mexico. I'm Lakota, and I'll be sharing with you some Lakota words for my research. a word for research in Lakota, and I basically make pretty pictures of galaxies for a living, and I make images of galaxies. And so what you see here on the left is a James Webb Space Telescope. It's a new image that I was able to make this year, and this is a galaxy very, very far away. And I work on a survey called Chiles, and it's done with the VLA telescope that's just outside of Socorro. And we make these images of galaxies very far away. And on the right side, the black and white is a Hubble Space Telescope image of a galaxy. And the purple contours are the data that I get from the telescope, and it's the gas around the galaxies. So simply put, galaxies are made of stars and gas. And with the James Webb Space Telescope, you can see the stars. That's the bright part there. And I image the gas, which is the purple contours. So just as an outline for this talk, I'm going to share some of my language and my research, tell you a little bit about my story and where I'm from in South Dakota, and what the stars mean to the Lakota people and our connection with that. I'll also talk about our surroundings, which is New Mexico. New Mexico is an amazing place to be an astronomer. And I'll also show you some more pictures of the cosmic web, and I'll explain what that is. And then I'll show you some more of our art, the art from Agnes and her students, and then I'm going to give you some homework at the end of it. And so this is just my story, but I am an electrical engineer, more specifically a radio frequency engineer, and I'm also an astrophysicist, more specifically a radio astronomer. And I grew up in the middle of nowhere out in South Dakota, and I grew up looking up at the sky, looking at the clouds, and looking at the stars, and just wanting to be up there. And so I ended up becoming an engineer, and my childhood dream was to work at NASA, and I spent almost a decade there. So I'll show you some of those pictures. And I really didn't know you could do these things for a living. I didn't meet an engineer or an astrophysicist until I went to college. And so I just like to tell people you can do this for a living, and it's possible. And as I said before, in my everyday life, I make pretty pictures of galaxies. So it's pretty great. This is a picture of me at NASA. I'm floating in the zero gravity plane, and I don't know if anyone's ever seen that before, but it's a plane that does these parabolic maneuvers, and it emulates zero gravity. And so that's me standing on the side of the plane. You can see my hair. And the picture on the left is the Orion spacecraft, which will take people to the moon and even beyond that to Mars, and I worked on that spacecraft when I was at NASA. This is more pictures of that spacecraft, and the center one is last year the spacecraft orbited the moon, so that's an actual picture taken from the spacecraft itself of the moon. And so it's pretty spectacular to have worked on that and then to see it launch and be successful. And so we'll have many more missions to come. So I'm also an astronomer, and this is in my backyard, just with my telescope looking up in the night sky. One of the things I love about New Mexico is you have these velvety black skies where you can see so many stars, and there's so much light pollution everywhere you go, and I think it's very unique. New Mexico has skies like I've never seen before, so you're all really lucky to live here. You can see so many things when you go outside and just look up, which will be part of your homework. This is the Black Hills in South Dakota. This is where I'm from. This is the land of my people. And if you've never been there, I love camping. This is my favorite place to camp. It's a great place to visit. So I would encourage you to go there if you've never seen the Black Hills in South Dakota. So we have our own relationship to the stars. The image on the left, we have our own constellations, and one of them is called the Sacred Circle. It's something that you can see, especially in the fall. It's one of the best times to see, but our relationship to the stars is very intertwined with where we were on the land and what kind of ceremonies we did and activities we did. And so we had a very intertwined relationship to the night sky. And so it's amazing to me to go to school and be trained in Western science and have that complement what we already know about the stars as Lakota people. And also the way we live our lives as Indigenous people, we know that everything is related, everything is connected. And actually in physics, we learn that with mathematical equations. And so it's an amazing way that these two things come together. This little pictograph of South Dakota, just in case another advertisement for you to go and visit there. And so this is another picture of that sacred hoop that I was talking about. And the stars in the circles there, these are the brightest stars in the sky. And so it's very easy for you to go out and see this. And so I would encourage everyone to try to do that. And so you should be able, definitely in New Mexico, to see all these stars. And so this is one of our constellations. I also wanted to talk about our surroundings in New Mexico. And New Mexico is such an amazing place for astronomy. And I don't know if everyone knows this. We have the Very Large Array, which is the instrument that I use. It's just outside of Socorro. And this is the most productive ground-based telescope in the history of astronomy in the world. And I don't know if people really know that, what an amazing instrument this is. And also at Apache Point Observatory, there's a survey there called the Sloan Digital Sky Survey. This is one of the most cited surveys that's ever existed. And so these are pretty extraordinary things, and these are just happening in your backyard here. So it's an amazing place to be as an astronomer. So I want to show you some pictures that I make of the galaxies. And so in my research, I really try to understand how galaxies assemble, grow, and evolve. And I try to understand how galaxies acquire their gas. And galaxies are made of stars and gas, and you see the stars in the central part. The gas is further out from the center, and it's something you can see with a radio telescope. And so I try to understand how the gas comes into the galaxy. The gas is the raw fuel for the star formation. And so I try to understand, there's a large-scale structure to the universe. It's called the cosmic web, and I'll also show you some images for that. So this is basically what I study. This is an image of our data. And so it always reminded me of like static on the TV. And so if you look at that little square and it's zoomed in, that's a galaxy. And if you look at the spectrum, you see this little feature popping out, and there's a galaxy there. And so that's just kind of what our data actually looks like, our raw data. So this is my student that I'm working with, and this is a picture of two little tiny dwarf galaxies. And so our Milky Way galaxy is like a medium-sized galaxy, and we also have a lot of tiny galaxies. They're called dwarf galaxies. These two are very close together. And I want to show you, we can view our image cubes, our data in VR. And so I wanted to just show a movie. And so this is you looking from face on. And in a moment, you're going to go and look at the data from the side. And you're basically looking at two galaxies, these two dwarf galaxies in our data. And so now you're looking at it from the side. And you can fit two Milky Way galaxies in between these dwarf galaxies, just to give you a sense of the scale, the size. So then we're going to come around and zoom back around to the front again. And so basically this view is the picture that I showed you on the previous page. This is another galaxy that I study. On the left, this is a Hubble Space Telescope image, and what you see in the green are the stars in the galaxy. What you see on the right, the purple contours, it's kind of a zoomed out image, and the purple contours are the images that I make of the gas in the galaxy. And so the purple is the data that we take from the VLA telescope. And this is another galaxy. This is a very large galaxy. And this is the image on the right is just another way you can look at our data. Each square is like taking a snapshot, and then you go a little bit further and take another snapshot, and take another snapshot. And so if you play all these things together, it's kind of like a movie. You're kind of like moving through the galaxy. So these are like slices of the galaxy. And so I'm going to show you another movie. So we're looking at the galaxy from the side. This galaxy is 2.5 billion years back in time. And you're looking at it from the side. And our data is very complex. And as you'll see in a second, this is what the actual raw data looks like. And if you remember where that galaxy was in that square, it becomes very hard to find these things. And so that's what we spend a lot of our time doing, is like kind of digging through the noise to try to find these galaxies, and so you can see how it looks in our data. One of the other things I wanted to talk to you about is the large-scale structure of the universe. We also call it the cosmic web, and I don't know if anyone's ever heard about this, but it's really the cosmic web. If you could zoom out and look at the universe, it looks like a giant web of interconnected material, and there's really dense regions, and there's regions that are really less dense, and it kind of looks like bubbles. And what makes the web are individual galaxies. And so this is a simulation, a computer simulation of what it looks like. And each little point in there is a galaxy. And so I study how galaxies are connected to this cosmic web. This is my very first scientific paper. This is actual real data. And so this is a real picture of the cosmic web. And all of these little black dots in here are galaxies. And that data was taken by a telescope at Apache Point. And so all of this information comes from telescopes here in New Mexico. And so this is a real picture of the cosmic web, and these little pink squares are my galaxies. And I study how they grow and evolve in relation to the large-scale structure. Another thing I wanted to mention, and I think Agnes is going to talk a little bit more about this, is artificial intelligence, AI. We, as astronomers, have been using artificial intelligence for many, many years. And we call it machine learning. And we have so much information, our data sets are very massive, and there's so many different things that we need to look for, and it's becoming harder and harder to manually look at everything ourselves with our own eyes. And so we write these codes and we train them to look through our data and analyze things. And so we've been using artificial intelligence for years, and so it really helps us with our observations. One thing that I really wanted to talk about this, and you'll hear about this from Agnes, who's the next speaker, but she has an organization called STEMarts, and it's one of the coolest things I've ever seen, where they combined real science and cutting-edge technology and art together. And I've been working on several projects with her, and she'll talk a little bit more about this. They have space messengers, and I don't know, there was an installation at the Balloon Festival, and it's the size of a semi-truck, and it's a 3D installation that's interactive. And on one side there was the installation, on the other side there was an avatar projected on the side of the screen. That's a picture of me. I got to pick my outfit, and I wanted something that looked like Star Wars as much as possible. But it was really fun. If you ever see that, check it out. The second thing that I worked with Agnes and their students on is the International Design Challenge. The drawing that you see there, it was a student from Mexico, and it was one of my favorite ones. My favorite winners in the competition were when they tried to combine nature and animals into futuristic things. And so this student wanted to take the ability of an octopus and how they can morph into their surroundings and make shoes with that kind of material for outer space. And it was a really cool idea. Another thing, we have these boot camps where they bring in real scientists and talk about things, and then they do art the second part of the day informed by real science. And so you can see some of the drawings there that they made of the cosmic web, which are really amazing. There's also a podcast that you can listen to. I was on the podcast a couple weeks ago, which is really fun. And then we also are doing astro tours, and there's one July 12th in Taos. So you should check that out if you're in the area. But Agnes is the founder and mastermind of all of this, and so you'll hear more about it next. So I just want to wrap things up with giving you some homework, and I really want everyone to go outside and look up. And when I talk to students, I tell them that their homework is to do that at least once a week. And you are so blessed to be here in New Mexico and have the dark skies that you have. One of the things that I love to look at is Andromeda. This is our closest large galaxy. This is 2 million light years away. And we will eventually collide with Andromeda many billions of years from now. But you can see this with your eye if you go outside and look for it. And if you see in the center of the screen, that's kind of what it looks like. It'll look fainter than that, but that's kind of the scale that you see. And when I'm in Socorro and I'm sitting on my deck, I look out and I can see this galaxy with my own eyes, and it really just blows me away every day that I can do that. So I really want to encourage everyone to, to find Andromeda. And so one of the things that we all think about is how does all of this deepen our understanding of the universe, and that's something just to think about. My message really in this talk is I want everyone to know what an amazing place New Mexico is for our astronomy. And as an Indigenous person, we're very connected to the sky, and we live our lives knowing that everything is connected, and that's the fundamental principle of physics. And everything is connected in our woven skies. And so just remember to keep looking up. Thank you.
She's going to switch the presentation. I'm just curious how many people are traveled really far to get here. Raise your hands. Traveled really far to get here?
3 hours, 4 hours.
3 hours, 4 hours. How many live close by? Anybody? How close do you live?
2 hours away.
That's considered close in New Mexico, right? I love it. The future isn't written in the stars, it's up to the next generation to create it. So, as you can see, I work with youth, I work with young people. That's what I love to do. I'm going to start with a video. As Julia told you, we work together a lot. I work with scientists, and we work with youth to help them to communicate, to understand the universe through the lens of art, science, and technology. So I'm going to show you a video, which is like what we do, so you can just see it in its full completion state, and then I'll go back and explain to you how we do it.
What do you see out there in the dark? For thousands of years, we've looked to the stars to find our place in the universe. Reach out and feel the universe.
This was an installation we did in Taos, New Mexico, not too far, if you want to come out and visit us over there. We do an annual festival called the Paseo. So I'm an artist, but a lot of people ask me how did I get into science and why physics. It's the most asked question. Even my mom says to me, when did you become interested in science? And I had to really think about that question. And I think the answer is that as an artist, one of my purposes as an artist is exploring the universe, to understand my place in the universe. And when I discovered physicists, I realized they too are doing it. And they too are exploring these invisible realms. Artists are always exploring these invisible realms, trying to make visible what's invisible. So that's kind of what I realized in looking back, why I always kept finding myself wanting to work with scientists and more specifically physicists. So it was a long journey as an artist, creating art that was always inspired by science, but it was in 2009 that I started STEMarts Lab. And that was more specifically because I wanted to actually understand physics and go and do research at physics labs to understand it a little bit more, but mostly to collaborate with them. So what STEMarts does is we work with artists, we design and produce these SciArt installations together with the scientists, and then we bring in the youth and we build the youth program around it so they become part of all aspects, from learning the science to designing the way to communicate the science, and to finally presenting it like you saw the students were there presenting the work at these professional venues. So here is the Venn diagram that I created in 2009 and I still use it today. You can see that it's really about empowering. We do it through art, science, and technology, but here's another aspect that is very important in my work. It's not just about creating robots or about studying, spaceships. It's really more about imagining how we can make the world a better place. So there's a humanistic aspect to it. It's always developing artistic, scientific, and humanistic literacy. So you can see in the middle, the core mission is always developing that empathy and sense of humanity and imagining a future that a better world. Just real quickly, you'll see that it is an educational program, so we take students through, and you can see some of the outcomes. We really are big picture thinkers, right? Students perceive themselves as caretakers of the planet and as local global citizens, developing positive values and ethics for collaboration and community engagement. So how we do it, we have paid internships, we have ambassador programs, apprenticeship programs, boot camps. Here's some of our winners of the Girls Apprenticeship Program from Northern New Mexico. Here's this is the ambassador team that work on all of our events. And we have an international program, so they get to collaborate with students around the world, whether it be through WhatsApp or actually traveling to different countries to collaborate as we travel with these installations. This year we won an award from the Patrick McGovern Foundation to integrate AI, so we're bringing in experts into our boot camps and we're integrating AI into everything that we do. And I'm going to show you some more little clips of works created by students. So this one is Feliciana. She participated in that boot camp and learned about the cosmic web. And this was a piece that she did. She learned how to do coded art, creative coding with, it's called P5.js, which is a JavaScript language for artists. She learned it in very little time. And then her assignment was to communicate something that she learned from Julia.
This piece is about galaxy filaments, and galaxy filaments is another word for the cosmic web. As you see, there's specific loops, which are nodes, and they're connected by the strands. So if you kind of press on it, you can see that it separates a little bit, and it's kind of simulating how the web stretches and moves as things pass through it and pass by it. This code visualizes the cosmic web, which is the largest structures in the universe, that kind of is the background of the universe, if that makes sense. It represents the distribution of galaxies in the universe, where they are arrayed in long, interconnected filaments separated by vast voids.
That was a boot camp. So they really have impact on these students. Here's Shaylee. She learned how to do 3D modeling with Blender.
My name is Shaylee Gurgle, and I'm an STEMarts master. I actually agree with the models right here. It's an Orion particle ring that has like a blue and white light picture, and that is a picture that is similar to what Native Americans like to do. They're light hits, pottery, and different costumes.
My name is Ian Harrison, and I'm a STEMarts ambassador and instructor. I did the cosmic cartographer piece, which was inspired by me growing up in New Mexico, showing the landscapes, the river valleys, as well as all the highs and lows, as well as my love for space.
We also explored virtual reality last year at the Los Alamos Science Festival. Here are some clips from some otherworldly landscapes that they created using tilt brush, where you paint inside of the virtual space, and then we see projected what they're painting inside of their headsets. So as Julie was saying, we bring in real scientists to work with the students. Here kind of gives you a little glimpse of the artists and the scientists. At any particular moment, we have many artists and scientists coming through the program. Anyone out there that wants to collaborate with us, we're always open. We do a lot of remote now, so that we can reach students from all over, so you don't have to come in person to our boot camp. And of course, we connect them to so many partnerships that we work with. So another question I get a lot, because I keep doing work about space, so I finally have to answer the question, why space? I gravitate and always have gravitated to space, but it's emerging what it is I love about space. And first of all, developing space literacy, I believe, is very important. We are living in what's the second space age, and right now the narrative is really dominated by, space tourism and Elon Musk and all of these billionaires in space, but space has been around for so much longer and has another narrative that is so important to teach our students. And we do need to learn about the basic science of space as well. So developing core space literacy is core. And then expanding our identities as planetary citizens is really getting students to not see themselves just as part of their small community, but also as citizens of this planet Earth, in a way that builds empathy and a humanitarian mindset. This definition I put together with ChatGPT, and I really love it, because it didn't really exist. Like, I had to go and found out that it kind of put it together with everything that I've been exploring, and then it gave me the organizations that kind of follow this concept called space humanism, and of course all of these are organizations that I collaborate with. So I'm just going to read it real quick. Space humanism is an emerging perspective that applies humanistic values such as ethics, social responsibility, and the recognition of human dignity to space exploration and the expansion of human activities beyond Earth. It emphasizes the role of humanity in shaping the future of space in a way that prioritizes inclusivity, sustainability, and the well-being of all people, rather than just technological advancement or geopolitical interests. And I'm very much a social artist as well. A lot of my work is very much based in making our community stronger. And so I really love to bring in the space and also the community work here on Earth. So, this is the project that I want to talk to you about. It started during COVID and has been traveling around the world. It's called Space Messengers. It's an immersive mixed reality installation and, of course, an international media exchange. This was the balloon fiesta where Julia was an avatar. So you're going to see a little bit, a glimpse of what this installation is.
For example, we're here in the present, working to create a vision or visions about what a sustainable futures might look like.
I would consider it as a life-changing experience. It was like, oh well, it's science, but it's also technology and it's also art.
Let me ask you to think about our universe as a kind of a flexible fabric.
One of these cosmic rays comes in and hits it. Ding, 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 ding. I don't know, personally, it's a lot of fun.
It's going to change the way that we think about how the universe has evolved, especially in the early universe.
Working with the investors, I have definitely seen them grow their communication skills and professional skills when it comes to developing their own personal careers.
I've learned a lot of technical stuff, like how to set up different equipment, how to use virtual reality headsets. I've learned how to communicate with people.
Not only are they participating to help the installation come together, they're also learning skills that will help them in the future outside of the installation.
We have always believed that we are stardust people and that we come from the stars.
So we're so glad you're here. This is incredible.
It's just a really good sense of belonging in bringing all of this project together with everyone and seeing it from day one to what it is today.
1, 2, 3, and this one we were invited to bring it to Portugal. You're going to see that there are these little round video clips. What we do is we collect these clips from our visiting scientists and artists and even the students. And that's what you're seeing in these videos. And those messages that you see floating are also messages from all the participants, as well as the people at the events who are contributing their own space messages.
So this concept of debris is really, really dangerous, not only for humans in space, but for all of the other wonderful things we have in space.
We are creatures that live on a rock in space, so we have a very limited experience of the universe, but through science and through mathematics and through all these schools, we can get a glimpse of enormous scales of space-time, of the beginning of the universe.
It's going to be a long journey to get there, but is within our lifetimes to be reached.
Eu gostaria de ter um projeto desta escola porque eu gosto de tecnologia e também misturar com o espaço, gostaria bastante.
We bring protons right through each other. The way we measure what happens is we build these detectors.
Foi uma experiência muito gira e nós nunca tínhamos visto.
Desta forma é muito melhor para nós podermos experienciar o espaço do que aprender de um livro.
out with the public. So you all, as the public, gets to also get a glimpse into this mindset. So the last thing I wanted to share with you is what's next. So because of this funding that we got with AI, we're now going to use AI to take space messengers to the next level. So we're creating an LLM, a large language model. It's a vertical agent, and you're going to see it here. So what we're doing is that we've kind of tagged all of the messages now. There are thousands of messages, and we're going to keep collecting them. But they were just floating up before, you noticed? And so if you walked up to the installation, you would only get a little glimpse of all these wonderful little voices of the community and of the world. Now we're tagging them with these categories. And a little bit more of like the scientists, I'll just play one more.
Turns out that human beings, since the beginning of time, have a lot of really big questions. Where do we come from? What are we made out of? How do we measure what we can't see? This question is at the heart of science. Well, there's different ways that we do that. By exploring, building devices that allow us to see more. We also do it by what I call extrapolation, thinking about things. Based on what we've seen, what do we know? When we look out, what have we learned? Galileo, he came up with this idea of using glass to build a telescope and to look out into space. We also listen out. Recently there's an experiment called the LIGO experiment and also the Virgo experiment. They can actually measure whether space-time itself has changed. When we look out at the light that comes from way far away, the further ones we look at are older, and so we have figured out exactly how our universe expanded over the course of time. I've come a long way.
So a little bit more of the scientists that we work with.
We're editing.
I'm just going to move on a little bit faster. So ethics and policy, as I mentioned, is really a strong part of what we do, so that we're not just mindlessly moving out into the world, exploring space without being careful about the impacts. So we bring in a space lawyer, which is Michelle.
The Committee on the Peaceful Uses of Outer Space is a United Nations agency. It has 104 members now, and they meet 3 times a year to talk about things like debris mitigation. They have recently established a working group on space, the sustainable development and exploration of space, and they came up with 21 guidelines to guide how we are going to make sure we use and harness and explore space sustainably.
I don't know what happened to her voice there, but a lot of people don't know about this, that we actually have this outer space treaty since 1967, and I was just at the United Nations, and they're actually making it one of the 18 Sustainable Development Goals, and they are really making sure that we have laws to protect what's happening in space. And now that it's happening so fast, they really have to meet a lot to cover the loopholes and to try to find ways to make sure that it's being protected. The Universal Declaration of Human Rights, all of this content we're putting into our LLM, so that when people put in their messages and write their messages, our AI model is going to be bringing this information to the viewer as well. Ethics and policy. Here are some of our messages from some of our students that were in the program or just typing it while they were at the event, so you get a sense of what are these space messages and how do we make space travel equitable so the unfair socioeconomic gaps that plague our society today don't manifest themselves once in space. These are the big questions that they're asking, in addition to questions about the science. Futures thinking.
By grappling with the past and the stories we tell about it, and how that impacts our present, we can actively choose to take a different path in the future. And that's really, really exciting to me. Space exploration doesn't have to just be a final frontier. It can be the start of a transformative change in how we think about our relationships to other forms of life, to land, and ultimately to each other.
Some more messages from our students. And nature, we also encourage poetic reflections on our place in the universe. We give some examples from mathematicians and physicists as well. There is the Universal Declaration of the Rights of Mother Earth, and we have all those principles in there in the LLM as well. And now the last thing I wanted to show you is what is new about the visualization of the new Space Messengers AI. So here you see from far away, you'll be really interested in this, Julia, you haven't seen it yet. So we took all those messages, now they're tagged, and you can see as I start to get closer, these are the thousands of messages that have been collected and will continue to be collected, and they're tagged by these categories. Here you can see something someone's grandmother wrote, wishes for exquisite social equality, comfortable interplanetary travel, and she says she wishes she could go. So you get people who put whatever they want to share, and here you get a little closer, see some more of the messages, and what we're going to be doing with this is that people will be able to use their bodies like in that video you saw, but now they'll be able to go into the database and kind of go deeper to discover more about what people are saying, and you can contribute your own messages. So to end the presentation, we can't do this because there's no internet, I found out. So you can't scan that, but if you could, you would get to a page that, yeah, you could snap a picture of it, you could do it later. You could send your space message to become part of our Traveling Space Messengers installation, which we hope will inspire other people to really learn the science behind space, but also the social, the philosophical, and just the imaginary. You know, how can we imagine a future in this Earth and as part of the universe, and what is our place in this universe? That's what we try to share with our students. So, all our sponsors, thank you very much. And more QR codes that you can, but you can take a picture of it and scan it later. Thank you so much.
Now, I understand that Agnes and Julia are willing to take questions, if you have any questions. Anyone, or comments? Can you put those QR codes back up?
Yeah. Oops. You want to?
George has a question?
Yeah, I was wondering how all the gases come together. Maybe I missed that.
So that's what we try to figure out. And with the images, we study the content and something called the kinematics. We study actually how the gas moves and how it comes in. It can come in from in a spherical way, like all around the galaxy, or it can come in within little streams. So that's one of the things that we try to find out.
And what draws it in?
The gravity. The gravity, and it's smaller galaxies grow by accreting this gas along these cosmic web filaments. And bigger galaxies are perpendicular to the cosmic web because they merge along the filament, and so it comes in different ways, and that's one of the things that we try to find out.
So the starting up of the original gravitational thing is still kind of a mystery in a way. What is it that the teeny tiny galaxy, where does that get its gravitation?
It all comes together. You know, the stars form from little dust particles, and that comes together, and that forms a cloud, and then that forms stars, and then those stars come together, and everything has gravity, and then all that comes together to form a galaxy, and the galaxy has gravity that pulls in gas from the larger environment.
And then the reverse happens when they blow apart, right?
Yes.
Yes.
So when
Cool.
stars age, they have explosions, and they have all the elements that they make, the heavier elements. When they explode, all that goes out into the universe, and that's actually what we're made of. And so if you've ever heard that saying that we're made of stardust, it's really true. And you're made from stardust from many different stars.
There was another question out there?
I think you answered my question. I was going to ask about your study of galactic gas, and if it was primarily looking at interstellar gas rather than gas in the stars themselves. That's what you're focusing on?
Yes, so you can focus more on the stars and the environment around the stars, but I study something on a much bigger scale. So just the galaxy itself.
Yeah. Do you have a sense of like what percent of the mass of a galaxy is composed of this interstellar gas? I'm sure it varies by age.
Yeah, that's one of the things that we try to find out. The way you characterize galaxies is usually by their stellar mass. So if you add up all the stars, how heavy, what is the mass of the galaxy, then you can also figure out the mass of the galaxy in the gas. And actually that changes as you go back in time. There's predictions about that. And so we're trying to fill in those measurements and see if they are what the predictions say. So that's one of the things that we do.
Where do you work? Where do both of you work?
So I graduated recently in 2021, and I was a postdoc at the Very Large Array in Socorro. And so I'm there now, still looking at my data and analyzing my data.
So is that the feds? Is that a local organization?
It's the National Radio Astronomy Observatory. They run several telescopes, and the Very Large Array is one of those. And so I use that instrument and that data.
And you started the STEMarts program?
Yeah, I'm based in Taos, New Mexico.
Got it.
And travel around, but that's my home, that's my base. Originally from New York.
Thank you.
Mm-hmm. Any other questions? Yes?
So I'm wondering about the mental health aspects of this, in the sense that, like, when you really start realizing how big everything is, do people go crazy? Or do they just sort of expand? I mean, I could see both happening. It's like, I don't know, they just like balloon their consciousness. I don't know. It just occurred to me, like, after hearing you both talk.
Actually, it's interesting. So I'm a Trekkie, and I've always had a very, I don't know, just like a connection to space. I feel good thinking about space, but I have come across people who it really makes them feel fearful. And there's a name for it. What is it called? Who knows the name of fear of space? It's a thing. It's actually a thing. I looked it up, and there's a real fear. They feel like it makes them feel afraid that it's so big and not understandable. So I guess you have to see where you fall in that camp, or somewhere in the middle. Probably most people fall. I mean, us, obviously we connect with space, but not everybody does. Some people. Where do you fall in that spectrum?
I think I'm deliciously straddling both. Sometimes it's like, oh my God, this is just, I can't even begin to comprehend it. And it is scary, but then sometimes it's fun to be scared. And then the other way, it's like, wow, it just sort of opens, sort of in both directions. Because then if I think this, well then what happens if you go the other way and into the, whatever they're saying, the protons and neutrinos, and then this body which seems so solid is maybe just, so porous. I don't know.
Yeah, I mean, when I hear, I love subatomic physics as well as the macro, and I feel more connected to the universe when I learn about it. And my hope is that my students will feel that way as well. But I'm wondering how many people feel connected to space. Raise your hand. Versus connected, good, excited. Raise your hands. How many people feel a little bit afraid of the big, wide open space? Okay. Well, you're here, right, for Astronomer's Night, so that's a hint. Any other questions before we go look at the stars? Thank you for being here.
Thank you for being here.